automatic or the synchronized sequence, which are the final moments of the final countdown, the tip of the iceberg, if you like. What's happening, basically, power's passing from the ground, which controls everything now, to the onboard computers on the launcher, making her autonomous. All right, you know everything. Our stage is set. We'll go for launch. I'm going to make my way up to the broadcast booth, and while I'm doing that, take a look at a film on the launcher campaign to see how Ariane is put together.
Saudi geostationary satellite 1 Hellasat 4 was flown to French Guiana on an Antonov aircraft, arriving at Cayenne's Félix Éboué airport. It was then transported by road from Cayenne to the European spaceport in Kourou. Saudi geostationary satellite 1 Hellasat 4 was installed in the S5C South facility in order to begin the preparation phase. The satellite was then transferred to fueling building S5B, where the Lockheed Martin team filled its tanks. The GSAT-31 satellite was also flown to French Guiana on an Antonov aircraft, arriving at Cayenne's Félix Éboué airport. It was then transported to the spaceport along with all allied equipment and placed in the S5C North facility for preparation. The satellite was then transferred to fueling building S5A, where the ISRO team filled its tanks. Combined operations involving Saudi geostationary satellite 1 Hellasat 4 and the launch vehicle began at D-11 in the S5B building with the integration of the satellite on its flight adapter.
After assembly of the launch vehicle and checks on the electrical and propulsion systems, it was placed in secure standby on December 17th, then transferred to the final assembly building on January 17th. Combined satellite launch vehicle operations were initiated on January 21st. The satellites were assembled on the launch vehicle and all launch vehicle systems placed in flight configuration.
The satellite was then transferred to the final assembly building to be integrated on the Scylla structure, placed under the fairing and integrated the launch vehicle with the upper composite. Combined operations for GSAT-31 and the launcher started at D-8 in the S5A facility with integration on its flight adapter. The satellite was then transferred to the final assembly building to be directly mated onto the launch vehicle and encapsulated with the upper composite at D-6. Since D-6, the two payloads have been subjected to health checks and battery charging. Saudi geostationary satellite 1 Hellasat 4 and GSAT-31 are now both on top of the launch vehicle and standing by for the final countdown.
I would like to thank the launch team for its hard work and commitment.
All right, Joshua Jampel back up here in the broadcast booth for the first launch of the year for Arianespace, first Ariane 5 and the first two satellites of the year. There are some 1,700 people working around the space base in all, and our cameras are here in Jupiter, but many others are hard at work at many other sites across the range. And we want to bring you some of those. The range in all is large, about the size of Singapore or about the size of the island of Martinique. We're going to show you in just a moment one of those places where there's a lot of work being done now. It's up in the launch zone where the launch management teams are working under the direction of the Launch Complex Operations Manager. Today, Patrick Lucette in the role. Now, most of their work was done earlier in the day. By the time we get to the automatic sequence here, the 7-minute mark, they, like most of us, like the launch vehicle itself, are waiting mainly. The work done up there carried out by two teams, one responsible for executing flight chronology, and the other for verification of the flight worthiness of the Ariane 5 vehicle. Now, the Launch Complex Operations Manager heads up the group responsible for execution of the chronology. Now, he coordinates with Mission Control back here for final authorization to launch. And when all the conditions are right, he then okays the automatic sequence at the 7-minute mark, which we saw. They are closer to the launch pad than we are. Here in Jupiter, we're about 15 kilometers away, but they are right there. We mentioned earlier, countdown is a complicated process and a long one. Final countdown actually began around 6 this morning with first checks of the electrical services and the inertial platform. Filling of the lower stage began at 1 o'clock. Filling the upper stage began about 3 hours ago. This split-screen image shows the propellant feeder arms in the middle of the launcher. We're going to pull back and you get a better view in just a second. Liquid hydrogen on the right, on the left, sorry, liquid oxygen on the right. They're putting propellant into the upper stage tanks. Now these arms pull back at -7 seconds before ignition. You see them in the middle of the screen, the yellow bars running from the gantry into the upper stage. One of the last things you'll see before liftoff, so we want to take a minute and mention it. Minute and a half to go. The electrical power supply has been switched from the ground to on board, and here in Jupiter, the VIPs and the invited guests have begun to make their ways outside to watch the liftoff. There are 2 terraces, as you may know, on either side of the building that give a fine view.
À tous de DDO, attention pour moins 1 minute.
The DDO is going to call out the 1-minute mark.
Top H0 moins 1 minute.
All right, we're into the final 60 seconds. Give us a chance to say hello to our friends at ISRO and Bengaluru, to all of our friends at KAXT and at Helisat and at Arabsat, to Lockheed Martin in the US, locally to the Kourou, Sinnamary, and Cayenne sites, to our industrial partners ESA and CNES, and to all of you following the broadcast on the internet. We hope you are enjoying it. If you're not settled in, pull up a chair and you can enjoy all the action. And that's about to begin. We're going to cut away, let you listen to the DDO for the final countdown.
À tous de DDO, attention pour le décompte final. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, top. Allumage Vulcain. Allumage des deux AP, décollage Ariane VA 247.
Local time and right on time.
La propulsion est nominale.
Mission, lifting off from the ground here in French Guiana with a lot of fire, carrying 2 new satellites. We lost her into the clouds. We didn't have much visibility, but we did have liftoff. The 2 boosters now providing 90% of our thrust, propelling the launcher along her trajectory at an ever higher velocity, as the DDO says all is working perfectly on board. Our mass at liftoff, 775 tons. And to get that sort of weight off the ground, you need a lot of push, and push we have. She's burning 5 tons of fuel every second. That's 2.5 tons per second burning in each booster, plus the core stage burning another 300 kilos of fuel, again, every second. Ariane 5 is now following the program in the onboard computer, which gives all the orders, including stage separations, which we will soon see in less than a minute.
Tous les paramètres à bord sont nominaux, la propulsion est nominale.
The DDO says all is working fine on board. We're in the first of 4 flight phases. We'll describe each in turn and in detail so you can follow Ariane as she heads east across the Atlantic. Right now, the first flight phase,
La trajectoire est nominale.
the single first stage engine and the 2 boosters are burning. The boosters will each consume their 240 tons in just over 2 minutes. In about 20 seconds, they will be extinguished, and they're the first to be jettisoned, and you'll hear that from the DDO, and you'll see that, of course, on the animation as well. This first flight phase, using both cryogenic cold fuel and storable propellant. Cryogenic offering certain advantages over storable, better and more precise performance, and its motors can be reignited. There we have right on time separation of the 2 boosters.
Séparation des 2 EAP.
The DDO confirms it. They fall 500 kilometers from shore into a protected area. Give you an idea what it looks like from the onboard camera. There is a second booster to the port side of the ship, which is out of camera range. French Guiana was in part chosen as a base for its opening on the water, launches posing no threat to the local population. We'll have more on that coming up. For now, On the bottom of your screen, take a look on the left, our altitude approaching 100 kilometers. And on the right, our speed. We've passed 2 kilometers per second. The speed we need for satellite separation, roughly 9 kilometers per second. So keep your eyes on the numbers. And when we near the region of 9 kilometers per second, we're getting near satellite separation. Fairing separation has come right on time. Separation given by 2 pyrotechnic systems, one horizontal and one vertical. They're cords that actually remove the fairing by a small contained explosion, and we emphasize contained, of course. We can separate the fairing now because we are out of the dense layers of the atmosphere. Over 100 kilometers up, there's neither friction nor heating, which could disturb the passengers. Also, we can discard any dead weight when possible to maximize the launcher's performance. The fairing weighs 2.5 tons, so it's good to get rid of it when we can. Ariane 5 is the heavy lift launcher. The 2 other members of the family, Soyuz, you know, lifting middle-sized payloads 2 and 3 tons, and Vega, the light lift vehicle for missions of 1 ton roughly. With its family of launch vehicles, Ariane Space is the reference, providing launches of any mass to any orbit at any time. And Ariane Space is part of Europe's space effort, which is a 3-way affair among ESA, CNES, and Ariane Space, and you find them all here along with the customers. Ariane Space is in charge of operating the family of launchers and of marketing launch services and the Ariane program. ESA, in a nutshell, funding new programs, and the CNES overseeing coordination of all space-based operations. The Guyana Space Center, the world's only dedicated commercial space base, where Ariane Space operating the launcher family Ariane 5 and soon to be Ariane 6, Soyuz and Vega, soon to be the updated Vega C. Ariane Space also managing the launcher and the satellite campaigns. We have the first of many films coming up for you now. We'll have films on both customers later on. For now, on the community of Ariane cities, highlighting towns that are part of the Ariane program.
En 2019 se cumplen 500 años de la primera expedición de la Vuelta al Mundo que partió de Sevilla, esa Vuelta al Mundo de Magallanes y Elcano. Entonces Sevilla era la capital económica del mundo. El próximo año, 2019, a la presidencia de la Comunidad de Ciudades Ariane la ostentará la ciudad de Sevilla. Es una enorme oportunidad y también un orgullo el centrar el interés de todo el sector aeroespacial en nuestra ciudad. Desde 2012 pertenecemos a la Comunidad de Ciudades Ariane y en ella hemos trabajado con otras ciudades para intentar que la inversión pública y privada haga del sector aeroespacial uno de nuestros motores de la economía. Para nosotros la oportunidad de esta presidencia de la Comunidad de Ciudades Ariane tiene también su broche de oro con la celebración de un Consejo de Ministros de la Agencia Espacial Europea en nuestra ciudad, en donde además se van a discutir importantes inversiones para los próximos años en este sector. Estoy convencido de que los debates que se produzcan, las reflexiones sobre la financiación y los modelos de inversión para estos proyectos van a hacer de Sevilla, sin duda, el centro de la atención mundial en la industria aeroespacial.
If you followed our launch last December, where we had, as a matter of fact, another GSAT, we also had a delegation from the community of Ariane cities from Les Mureaux, French town. Tonight, Sevilla, in English Seville, of course. CVA is a non-profit outfit aiming to strengthen cooperation among cities and organizations involved in Europe's space programs. We, meanwhile, are in the second powered flight phase, the single-engine core stage burning now. The boosters have done their job. Another minute to go before it shuts down. During the film on Seville, we were picked up by our first downrange tracking station. We're going to go to a launch replay, the first of what we hope are many. You can relive those very exciting moments 8 minutes ago. We have cameras at several of the observation sites here across the base. And throughout the broadcast and at the end, we will be bringing you replays, like this one is another one from closer viewpoint. The Natal station, the downrange tracking station, run by Brazil's Defense Department, it sees the lower stage burnout and separation. All of Ariane's trajectory has been designed to be followed from the ground, of course. We're waiting for confirmation of the shutdown of the lower stage and its separation. There you can see falling back into the Atlantic and the ignition of the upper stage. There's 3 commands given by the onboard computer in about 13 seconds. The lower stage falls back into the Atlantic off the Gulf of Guinea, which brings us into the third and final powered flight phase, the single upper stage engine that'll burning until plus 25 minutes, another 16 minutes roughly. And what is the job of the upper stage, you may be asking? That is a good question. The upper stage takes the satellites to their injection point, positions them for separation, and then releases them. That's its propulsion role. But she also has a second role, which comes during the ballistics phase, is what they call the non-powered flight phase. And we'll have more on that coming up. For now, turning to our passengers, a film, our first look at HELSAT 4 SGS-1.
Regarding in particular Saudi geostationary satellite 1 HELSAT 4, Arianespace is proud for having been selected by Arabsat in 2015 to launch this satellite, which has been manufactured by Lockheed Martin based on a modernized, well-known A2100 bus. The satellite will be located at 39° east orbital location. It will provide Ka-band spot beams communication services for the Kingdom of Saudi Arabia and will offer advanced Ka-band beam communication services for HELSAT, the Arabsat subsidiary. I would like to thank all the teams that have been involved in this program. First, of course, our customer Arabsat, who always relied on Arianespace with a dedicated, very efficient teamwork all along the program. Secondly, CAX and HELSAT teams, who were always proactive and helpful during this smooth campaign and also in resolving issues when needed. And finally, Lockheed Martin, who always contributed with very constructive approaches and experienced, dedicated team.
Arianespace has been serving the Mideast since 1985, when it launched Arabsat 1A, the region's very first satellite. Arianespace also orbited the first satellites for Egypt, 1998, Libya, 2007, the United Arab Emirates in 2011, and Qatar in 2013. HS4 SGS-1 is the 11th Arabsat launched by Arianespace and the 22nd to be orbited for the Mideast. Another look now for more on the satellite.
Our power to communicate is the very basis, the essence of human civilization. Satellites unlock the ability to reliably connect from across the most remote places, transforming our understanding of the world and the way we live, work, and cooperate on a global scale.
From the ancient times, Greece and Cyprus were the bridge of civilizations and the crossroads of trade between Middle East, Africa, and Europe. Our ambition is HELSAT to play this role, to be the window and the step of Middle East and Africa to Europe.
HELSAT 4 is a powerful addition to our network and a major milestone to our business plan. It brings new capacity that will enable our existing and new customers to unlock growth opportunities in broadcasting, mobility, and private data networks.
HELSAT 4 will be placed in our orbital slot at 39 degrees east. The goal is to complement the extensive coverage of HeLaSat-3, our latest satellite, which was launched 19 months ago, and provide in-orbit backup solutions to our customers. Our vision is to offer high-quality, cost-effective satellite service that will enable our customers to grow their business in the most remote areas.
HeLaSat-4 is the largest commercial satellite that Lockheed Martin built to date. It has electric propulsion with high-performance electric propellers and powered by the noble gas engine. It features 20 kilowatt sun burners and a weight mass of more than 6 tons, achieving a lifetime of more than 23 years.
HeLaSat-4 will be launched by Ariane 5 in VA-247 Ariane Space mission, keeping the great experience the company had from the launch of HeLaSat-3 back in 2017. The satellite covers Europe, Middle East, and South Africa with KU and KA payload. In Europe, the satellite will expand HeLaSat capability with 22 additional KU, FSS, and BSS transponders. In Middle East will provide 6 additional transponders, which can be used to provide 100% redundancy to HeLaSat-3 in the area. In South Africa, it will expand HeLaSat capability with 6 additional transponders, addressing the need of satellite capacity in the area. The satellite will be monitored and controlled by a team of expert, fully certified engineers through HeLaSat hot redundant facilities in Greece and Cyprus. A properly designed, built, and launched segment requires a respectively advanced level of flight operations so as to achieve the maximum of the satellite lifetime and the best of the service provisioning to the satellite customers. Offering premium satellite services since 2001, HeLaSat premiered with HeLaSat-2, positioned in 39 degrees east orbital position. After the successful launch of HeLaSat-3 in 2017, HeLaSat is now ready to welcome HeLaSat-4, the new addition to our fleet, offering unprecedented capacity to our already extensive network.
The universe is expanding. So are we.
While you were watching the film, we were picked up by our next downrange tracking station, Ascension Island, tiny island in the South Atlantic. 11 minutes to go in the upper stage burn. Arabsat, the direct client for both satellite, founded in 1976, headquartered in Riyadh. 2 satellite control centers, one in Riyadh, one in Tunis, serving more than 80 countries across the Mideast, Africa, and Europe. Another look now at our first passenger with more on CAXT.
La propulsion est nominale, le pilotage est calme.
King Abdulaziz City for Science and Technology, CAXT, is keen in investing in the technology of the future, which led to the creation of the Advanced Research Program. The program consists of several joint centers of excellence with prestigious U.S. academic and industrial entities, including MIT, Stanford, Caltech, University of California, Berkeley, and Boeing. Each center has been created to cover a strategic domain of interest that is vital to the development and prosperity of the kingdom, such as the energy, water, mobility, and health domains. Energy has always been critical to Saudi Arabia. Roaring growth in domestic oil consumption imposes challenges in finding other means of producing efficient energy. Saudi Arabia is the largest country in the world with no natural bodies of water. It is now beginning to feel the impact of rapidly rising water demand, which requires innovating in new water technologies. The kingdom has capitalized on its massive fossil fuel resources by successfully building a petrochemical powerhouse that is recognized worldwide. With this edge, it is crucial to keep up with the evolution in this field by innovating in advanced material and manufacturing. Rapidly evolving technologies, along with demographic and economic changes, are expected to alter the healthcare system worldwide. This demands an extensive effort to advance health technologies. The population of Saudi Arabia is growing rapidly. Major Saudi cities face increasingly severe traffic congestion and accidents and deteriorating air quality. Developing new smart mobility solutions in the kingdom is crucial to reduce these effects. Space applications are fundamental tools for bringing sustainable development throughout the world. Saudi Arabia is investing in space and astronautics technologies to strengthen its position in telecommunications, disaster management, agriculture, environmental protection, and natural resource management. Saudi Arabia is taking the challenge of finding innovative methods to produce fresh food to its citizens in a place that has scarce freshwater resources. Information and communication technology is the new source of economic growth and development around the world. Nowadays, ICT is almost an essential enabler of all other domains. Every human-made system begins and ends with the environment. The harsh desert environment of Saudi Arabia demands that engineered systems be especially resilient to survive such conditions.
La propulsion est nominale, le pilotage est calme.
Ariane 5 continues to function flawlessly. Arianespace coming off a very good year in 2018. We spoke briefly with Stefan Israel about it. 11 launches we launched in every month except in February and May, but we launched twice in November and twice in December. 11 launches, 4 double launches, telecom satellites, navigation, space science, Earth observation. Satellites went to geostationary transfer orbit and sun synchronous orbit. When I said Arianespace flies to all orbits, I meant it. Next up, a second film on our second passenger, this time on the prime contractor Lockheed Martin.
Les paramètres à bord sont nominaux, le pilotage est calme, la trajectoire est nominale. paramètres à bord sont nominaux, la propulsion est nominale. Il reste moins de 4 minutes de propulsion de l'ESCA.
HS-4, SGS-1 is the 46th Lockheed Martin satellite to be launched by Arianespace. There's another one in the backlog due for launch later this year. Our last launch for Lockheed Martin goes back to 2012, Flight 206, with the JCSat-13 and Venusat for Vietnam, both satellites built by the companies. We had a Lockheed charter. Some more numbers for you. This launch is the 306th mission performed by the Ariane family and the 103rd on an Ariane 5. Up next, a look at the relationship between Hellasat SGS and Arianespace.
I'm pleased to welcome this first Ariane 5 commercial launch of the year with on board 2 passengers. Saudi geostationary satellite 1 Hellasat 4 as upper passenger, a Condosat for CACST and Hellasat operators, along with GSAT 31 as lower passenger for ISRO.
The Saudi geostationary satellite SGS-1 is the national satellite, provides secure satellite communication on the Ka band for the government of Saudi Arabia. It provides 35 gigabit per second. It has the coverage of the Middle East, Europe, North Africa, and as well as a Ku band payload for the Hellasat subsidiary of Arabsat. SGS-1 is a satellite that comes out of the alliance of the agreement between CACST, Arabsat, who jointly contracted Lockheed Martin to build 2 geostationary satellites. CACS is honored that it can provide the satellite in the name of Saudi Arabia thanks to the support of the custodian of Tuliham Mosque and King Salman and the overseeing of the Crown Prince, who made the visit and monitored their manufacturing activities and wrote a precious word above the highest cloud, a sign of a new era of a new Saudi satellite on the geostationary orbit at 36,000 kilometers that comes after 15 Saudi-made satellites previously launched by CACS on the lower Earth orbit. I would like to thank His Highness Dr. Turki Al Saud, former president of CACS, and chairman and president of CACS, Mr. Khalid Al Faleh.
The HELASAT payload will provide KU coverage over Europe, Middle East, and South Africa. It will provide extensive redundancy and backup capacities to further secure DTH networks and customer base and provide competitive advantage to its customers in Europe and other areas. We envision HELASAT 4 to provide additional capacities for HD, 4K, and free-to-air channels, which will guarantee additional room for our existing and new customers to grow. Following the transfer orbit injection of the satellite, the Lockheed Martin Control Center in Colorado will begin the orbit raising operations with the support of Arabsat, CACS, and HELASAT engineering teams to bring the satellite into the geostationary position of 39 degrees east. With the completion of the in-orbit raising operations and the in-orbit test, the HELASAT SEC will assume the on-station operations and they will operate the spacecraft for the upcoming 23 years of orbital maneuver life.
We had a very accommodating and smooth launch campaign thanks to a team from CACS, Taqnia, Arabsat, and Lockheed Martin.
It has been a prosperous journey, and I would like to thank the Lockheed Martin team, the Ariane team, the Arabsat and CACS Taqnia teams for their support and excellent collaboration. I would like to thank my team, the HELASAT team, for the excellent job they did.
We are grateful for the cooperation and the service provided by Arianespace.
I wish a long life to Saudi geostationary satellite one HELASAT 4.
During the film, we were picked up by our last downrange tracking station. It's in Malindi in Kenya, and it will see the upper stage burnout and satellite separations. We are coming up on extinction of the upper stage engine. In just a few seconds, you will hear the DDO confirm that.
Extinction de l'étage supérieur cryotechnique.
DDO has confirmed it. You'll see the nozzle shutting down on the animation. And we are into the final flight phase, non-powered. We are coasting. However, we have not reached our maximum speed. You can see we're approaching 9.3 kilometers per second. Ariane's maximum speed will be 9.7 kilometers per second. After that, you'll begin to see her slow down. When she separates the first passenger in just about 2 minutes, her speed will be down to 9.4 kilometers per second, roughly. When she releases the Silda, that's the carrying structure for the second passenger, at plus 29 minutes, she'll be flying at 8.7 kilometers per second. And finally, when she separates GSAT 31 at plus 42 minutes, her speed will be down to under 7 kilometers per second. With the power shut down, not only do you see our speed start to drop, but we are moving into a new coasting phase. It's the last flight phase, the only one not powered, as we mentioned. Just a minute to go until separation of our first passenger. The time we have is plus 27:14, just in about a minute. And it's always a moan of high concentration when you're approaching satellite separation. The teams have gone through these procedures before, but it of course calls for tremendous focus. You don't want to say tense, but I think focused, concentrated. Gives you an idea of the atmosphere here in Jupiter. You see it on the faces. All eyes on the computer screens in front of them, and all ears on the phones as we await confirmation of our separation of our first passenger. HELASAT 4 SGS-1 coming in about 6 or 7 seconds, and you will hear the DDO confirm it.
Séparation Saudi Geostationary Satellite 1 et HELASAT 4.
Well, DDO has confirmed it. You see our first passenger pushed away from the mothership by a series of springs. First good news of the evening, successful separation of our first passenger at over 1,000 kilometers up over Africa and just below the Arabian Peninsula. You will also notice that people here in Jupiter politely holding their applause because the mission isn't over. We still have to separate our final passenger, GSAT 31. And we are in our ballistics phase, the final phase of the mission. When choosing a space base, the Europeans wanted nearby hills where radar and telemetry reception could be installed. You're looking at this place called the CVI, the Quick Look Telemetry Display Control Center. It's on a hill just behind us in Jupiter, and it's another place with the launch zone that we saw at the top of the broadcast that is very, very busy. These teams have all the means for receiving, processing, storing, and analyzing all the data coming in from the ground stations along Ariane's flight path. Remember, we talked about the downrange tracking stations that follow the launcher. Well, right now, these teams are following all the key flight data coming in, and they're reporting the flight data status of the launcher back to the teams here in Jupiter. The announcements you hear made by the DDO come from the CVI. The information goes to them first, and then to the flight desk, and to the Launch Complex Operations Manager. All part of the great information flow from points across the base back here to Jupiter. And so you understand Jupiter deserves its name as the nerve center of the space base. Later, these data will be treated to reconstitute the entire mission. The flight will be recreated in figures from liftoff to well after satellite separation and analyzed again. We are coming up on SILDA separation, as you see the names of the downrange tracking stations in yellow, the one currently following us. The SILDA is that black bell shape, which lets us carry a second passenger, and you will hear the DDO call out that separation.
Séparation du système de lancement double Ariane.
Coming right on time. The same system of springs pushing it away from the mothership, revealing our lower passenger, GSAT 31. Due for separation in about 8 minutes. GSAT 31, built by ISRO, the Indian Space Research Organization, of course. We mentioned Ariane 5, known for its double launches. She's the only commercial launcher capable of lifting 2 heavy satellites, and we've done hundreds. And each one requires a SILDA or the predecessors of the SILDA on previous versions of Ariane. The orbiting of GSAT 31, along with GSAT 30, which is an additional geostationary satellite due to be lofted soon by the European launch services provider, Arianespace, marks another vivid demonstration of the strong bond uniting Europe and India in space cooperation. The Indian Space Research Organization has a vision which is to harness space technology for national development while pursuing space science research as well as planetary exploration. ISRO also fosters the use of space to help develop the Indian subcontinent. Our second passenger now, another look at GSAT 31.
Please let me introduce GSAT 31, one of the 2 satellites to be launched by Ariane 5, flight VA247. GSAT 31 is an operational communication satellite designed and manufactured by ISRO, the Indian Space and Research Organization, in order to provide communication services from geostationary orbit for a mission life greater than 15 years. It derives its heritage from ILAS and GSAT 7, which were flown on earlier Ariane 5 launch vehicles. GSAT 31 will be the 23rd ISRO satellite launched by Arianespace, following the launch of GSAT 11 last December, also on Ariane 5. Our cooperation with the Indian Space and Research Organization goes back to 1981, when Ariane Flight L03 launched the Apple spacecraft. It is always with great pleasure that we welcome at CSG our Indian friends.
And our Indian friends, their second passenger due to be separated in about 10 minutes. ISRO, the Indian Space Research Organization, founded in 1969, having a birthday this year, I believe in August. ISRO's done so much for the nation, so important to India, using space technology for national development, pursuing, as we mentioned, space science research. With GSAT-31, ISRO will again foster the use of space to help bridge the digital divide on the Indian subcontinent. As was mentioned in the film by Alina, Arianespace launched an Apple experimental satellite for India back in 1981 that was on an Ariane 1, making India one of Arianespace's oldest customers. So you can imagine the strong bond linking Arianespace with India. The two have been cooperating nearly 40 years now in their long-term partnership. Since the launch of Apple, Arianespace has orbited 22 satellites, signed 24 launch contracts with the Indian Space Agency, also winning 89% of the geostationary orbit launch contracts open to non-Indian launch systems. More on our Indian satellite. A look at ISRO coming up.
Communication plays a very important role in the overall societal development. In a country like India, which has different geographical topology with many hilly and remote regions, effective communication through satellite becomes inevitable. For more than 3 decades, ISRO has launched and maintained a constellation of communication satellites, providing a variety of operational communication services in the country. GSAT-31 is a communication satellite which will provide continuity of services currently provided by INSAT-4CR and INSAT-4A.
GSAT-31 spacecraft is a high-power communication satellite with payloads in Ku